Okay, so we have a good number now. So mostly almost all of you have joined. So we can start the class. Okay, so prior to starting, so do you have any question from the previous classes? Anyone? Because the main part already we have covered. So today we'll be going to solve some problem, both from the normal gear drive as well as from gear train. Okay, so if you have any question, okay, you can ask in the meantime. So I hope all of you have understood the things, right? So in the last class, the gear train we have considered. Okay, we have discussed. So there are all those different types of gear train: simple, compound, reverted, episodic, click, etc. So those things already we have discussed, as well as we have done the small analysis on them. And there we have seen all those like terminologies like what is speed ratio, the train value, etc. And how what are the characteristics of a particular type of gear train. Okay, so what is idle gear and all those kind of things. Okay, how we can get the gear ratio for a particular gear train. Okay, so all those things we have discussed. So today what we'll do will be going for solving some small problems. Okay, so prior to solving the questions and all problems, okay, do you have anything to ask, any question? If no, then we'll move ahead to these particular questions, solving the problems. Let me know. Okay, no, no. Okay, so then we'll move ahead. So at first we'll be starting with a small problem from gear train, because gear train, the concept, I believe all of it is still a fresh in your mind, because that's in the last class we have covered them. And after this gear train problem, maybe some other problems from the previous things, that means contact ratio, all those part of research, part of contact, etc. Those kind of things from gear drive we'll be discussing. Okay, so first problem, we'll go to the first problem statement first. Okay, so what does it state? It states that a compound gear train, it consists of compound gears BC and DE. So they are the compound gears. All gears are mounted on parallel shaft. That means the shaft position, they are kind of parallel. So the motor shaft, it is rotating at 800 rpm, which is connected to gear A. Motor shaft means the driver shaft. That means the gear A becomes the driver. And the output shaft is connected to gear F. That is the follower is, or the ultimate follower, or the driven becomes the F, plus gear F. So now the number of teeth are given on A, B, C, D, E, and F gears as 24, 56, 30, 80, 32, and 72 respectively. So with this particular data, whatever has been given, you have to determine the speed of the driven gear F. Okay, so once you have this particular problem and you go through the problem statement, automatically what are the things that we understand? We already understand these things. That means a compound gear train, that is the thing. Okay, so compound gears in this compound gear train are the BC, this combination, as well as this combination from DE. Okay, next, so it is parallel shaft. Okay, all the gears are mounted on parallel shaft, and A is the driver, that is the motor shaft is connected, and output is F, and the number of gears are teeth are given. So with this data, now we can draw the, if the diagram is not given, it will be useful if you draw a simple diagram showing that particular compound gear train arrangement, then it will become easy. So as we know, compound gear train arrangement, what happens? So on a particular sub, in a single sub, we can have more than one gear. So just like here, it is given on compound gears are B, C, and D, E. That means on a single sub, B and C are mounted, and another single sub, D and D, these are mounted. Okay. So with this data, we have started what the look how we have considered. So from this data about the number of teeth, we can very easily have an idea whether that particular, suppose a gear which is having 24 number of teeth and another gear which is having 56 number of teeth. So automatically you can have an idea that the gear which is having consisting of 56 number number of teeth, definitely the size will be bigger. So considering that, we can draw like this. Okay, so now is we will be going through sequentially. That means A, B, C, D, E, and F, like that it is given. So now what we have shown, it is parallel shaft. So all the position of the center position, they are on this particular, it is not a zigzag kind of thing. Okay, so these are the center position, and this is gear A, which is in mesh with gear B. Okay, now as per the question, B and C, they are the compound gear. That means on the same shaft as that of B, C is also mounted. So gear C also will show here, and the size it comes from this. Okay, the data about the teeth. Okay, so gear B is, that means, bigger than that of gear C. That's why we are showing drawing like this. Now next compound gear is DE. Okay, so DE, that means it is also mounted on the same shaft. Now gear C, we are showing it is in mesh with gear D here. Okay, so, and D and E, as per the question, they are the another compound gear arrangement. That means they are mounted on the same shaft. That means D and E, in you can see from this figure, they are mounted on the same shaft, and once again E and F, they are engaged. Okay, so I believe figure is clear, and on the figure, that is for our understanding purpose, just the teeth we are just writing. Okay, and their name, that means A, B, C, D, E, and F, having teeth 24, 56, 30, 80, 32, and 72. Okay, so that's the thing. Understood up to this much? Easy only. So next, you'll be writing down. Okay, so next you can write down the given data about the number of teeth which are given. Okay, you write down the given data. Suppose teeth in, suppose TA. What is TA? That is T suffix A, means number of teeth in A. Similarly, TB, TC, and up to TF, you will just write down. Okay, those are the given data. Next, what we have to find out, some velocity is given about the motor shaft. That is the 800 rpm is given as the driving velocity for this gear A, and we have to find out the velocity for this final driven gear F. Okay, so what we can utilize from our previous knowledge, we can utilize the knowledge of the train value, where we know, if we know about the teeth on all the driving shaft or the driving gears, and on the teeth and all the driven gear, then if we consider the train value, which is the NF, okay, velocity we want, right? Okay, that's why NF by NA, what we can write from our previous knowledge, it is the nothing but the product of all the number of teeth on the driving gears divided by the product of all the number of teeth from the driven gear, because it's a compound gear train arrangement. Okay, so here the intermediate, as it is compound, it is not the simple one. Okay, so here the intermediate gears, okay, they also comes into picture. But if you recall from our previous knowledge, in the case of simple gear train, actually simple gear train, in the train value or the velocity ratio, the intermediate gears, they don't come into picture. Okay, right now it is a compound gear train. So what are the driving gears here in this from this particular figure? Can anyone tell me which are the gears which become driving gears? What are the driving gears? Which are the driven gears here in this arrangement?
Sir, A, C, E.
These are driving or driven? Yes, correct. Driving. So A, C, and E, they are the driving, and B, D, F, they are the driven. So number of teeth on A, C, E, this product we have considered, and number of teeth on B, D, F divided by that. Okay, so all these data are given. So automatically, if you just solve that value, 800 is already given for rotational velocity of A. So if we put all those values, we have obtained the velocity NF, that is the rotational speed of this final gear, driven gear F, is somewhat around 57.14 rpm. Okay, so now from this, that means 800 rpm was this particular it was 800 rpm. Okay, and from here in the final stage, what we have obtained, this value, okay, 57, around 57 rpm in the driven gear. Okay, so from this knowledge, can you tell me which whether it's a reduction type of gear train, or it is increasing the value? Definitely the speed, final speed, that has been reduced, so what we can write. So it's a reduction type gear train. Okay. If someone asks you to comment on the gear train, okay, what kind of gear train is this? Okay, then from the velocity we can say that it's a reduction type. Okay, so this completes this very simple problem. Understood? It's a very simple only. Once you are able to uh, draw this diagram, that means you know which are connect, which gears are in mesh, which gears are mounted on the same shafts and all. Okay, and we already have this knowledge about train value. Okay, so from that automatically we can, once we know that, we can very easily obtain this particular answer. Understood? Any confusion? I hope it should be clear. Let me know whether all of you have understood or not. As simple as that. Only you just have to find out this particular value. I hope all of you have understood. Okay. Now next we'll be going for some another problem from gear drive. Okay, right. And basically these are the type of problems. Some problems I have considered where we have to consider, suppose contact rate, like contact ratio, the minimum number of teeth which will be required to avoid interface, etc. That kind of problem. So what is the problem statement? We'll go through it. Now this problem statement says a two 20-degree involute spar gears, they mesh externally and give a velocity ratio of 3, which itself is identical to the gear ratio. Okay, the module is given as 3 mm and the addendum is equal to 1.1 times the module. If the pinion rotates at 120 rpm, determine, first one is the minimum number of teeth on each wheel to avoid interference. Second one is contact ratio. Okay, so once you have this question, automatically we understand. So what are the things? So whenever this kind of angle is given, 20-degree involutes per gear, so external meshing is given. So okay, so from there we can, this 20 degrees is nothing but the pressure angle that we are talking about. So given data we can write the pressure angle phi equal to 20 degree. Next, they are meshed externally, so these are for your you may not write it, but that is for your understanding. That means in which direction is rotate and all, and it is giving a velocity ratio or gear ratio of like 3. Okay, and the module is 3 mm and addendum is equal to 1.1 type module. So if the pinion rotates at 120 rpm, so that means np, p for p stands for pinion, and suffix p, 120 rpm it is given. Then the velocity ratio or the gear ratio, which will be ultimately useful in, if you recall this, if you remember, we have gone through this expression. So here those gear ratio, these things are required. Okay, module, gear ratio, number of teeth, etc. Those things are required. So that is given. So that z, that is gear ratio, it is given as 3, and the module is also given as 3 millimeter. So take care of the units. Okay, so module is generally given in millimeter only, and write down. So module small m with small m we denote. So m equal to 3 millimeter. Addendum is given as 1.1 times the module. Okay, so addendum equal to 1.1 into module. Okay, so from here, if you recall in the previous class, so this some addendum value is some coefficient, addendum coefficient into the module. So this 1.1, which is multiplied here with module, so that is nothing but the addendum coefficient. Okay, a suffix w. Okay, so it is for the so this is 1.1. Okay, next what they are asking, from this data you have to find out the minimum number of teeth on each wheel to avoid interference. Okay, so now in that case, what we can do, if you recall previous expression, we have standard expressions for finding out the minimum number of teeth on the gears as well as on the pinion so as to avoid interference. Okay, so this standard expression we can directly utilize, and that is what we are doing here. So we have minimum number of teeth, which is for gear, okay, which will be required to avoid interference, t suffix z, it is z for gear. Okay, and that is given as 2 whole into aw. Aw is nothing but the addendum coefficient, which we have found out from the value of addendum, and divided by root over 1 plus 1 by z whole into 1 by z plus 2 sine square phi minus 1. That is the known expression. That is the expression that we know. And we are directly putting this value, okay, putting the expression, and we are utilizing the value. 2 into AW, that is the addendum coefficient. It has been found as 1.1 from this value of addendum, okay, divided by 1 plus. So Z value is given as 3, okay, gear ratio. So phi value is nothing but the this is the pressure angle 20 degree it is given. So all those given data we have utilized, and we have found out 49.44 as the answer for the number of teeth on the gear so as to avoid interference. Now, can you tell me whether this particular value for teeth, this is the number of teeth, okay? So 49.44, is it a feasible value, actual feasible value? 49.44 as a number of teeth. Is it practical?
No, sir.
Definitely no. So the number of teeth, it has to be a whole number. 1, 2, 3, 4, like that. Okay. And from this knowledge of velocity ratio or the gear ratio, what we have seen, that means it is given as 3. Okay. That means gear ratio is nothing but the number of teeth in the gear, capital T by small t. That is divided by the number of teeth in pinion. Okay. So capital T by small t gives you the gear ratio. Okay, and now if we know that it has to be 3, that means this t value whichever we have just found out, t, this is for gear, this is for pinion, that is the bigger wheel and the smaller wheel, so it has to be divisible by 3. Okay, so 49.44 we have obtained. We know that it cannot be a fraction, it has to be a kind of whole number, and it has to be divisible by 3, because velocity ratio we have to obtain as per the question as 3. So what we have to consider, we'll be considering the next higher value of whole number which is divisible by the velocity ratio, and that is nothing but after 49, 50 is not divisible, so 51 is the number of teeth, actual number of teeth that we have to obtain. So final number of teeth, actual number of teeth on the gear is 51, which is also divisible by 3. Understood? Next, as per the question, you also have to find out the number of teeth on the pinion so as to avoid interference. So now there are two ways. One is the lengthy way, another is a somewhat smaller way, okay, short way. So see, either you can use this kind of another expression which is also available for pinion, okay, but here the z 1 by z becomes z and all. Later on you'll see. One way is to do that, and another way is to directly utilize the concept of velocity ratio or the gear ratio. So already one of the value of the teeth we already know, okay, so you can directly utilize the gear ratio or the velocity ratio, that concept, similar kind of concept, okay, and we can find out the number of teeth on the pinion. Okay, so what we know, z is gear ratio is tz by tp, that is number of teeth in the gear divided by number of teeth in the pinion. So just now we have found out tz to be 51, we know the gear ratio to be 3, and from there we can directly utilize 51 by 3 becomes the number of teeth on the pinion, which is equal to, which comes out to be 17. Okay, so that's the thing. So these are the two answers for the first case. Understood? Yes. Okay, I hope all of you have understood. Next, second part is we have to find out the contact ratio or the number of pairs of teeth which are in contact. Okay, so that is given by, we already have a standard expression for it. We know that the contact ratio, and it is given by, actually this is nothing but a ratio of arc of contact divided by the circular pitch. And how to find out the arc of contact? Arc of contact is nothing but path of contact divided by cos of the pressure angle, cos of phi. And circular pitch is what? So pitch we know it is pi d by t, or pi m is the pitch, okay, and it is divided by this, okay, circular pitch, that's why it is 1 by pi m. So directly up from here also you can start, from here also you can start, that is up to you. Once you are conversant with the formula and all, you can start from here also, no problem, because part of contact divided by cos phi itself is arc of contact. So here I am showing you by step fashion. Arc of contact is part of contact by cos phi, circular pitch is pi m. Okay, So now we already know for path of contact also we have got two parts. So path of contact approach plus path of recess, if you do, actually that gives you the whole path of contact. And we already have standard expression for it. So what is the path of contact? We can find out root over r a square minus r square cos of phi minus r sine of phi, that is for the first part, that is the path of approach, plus if you see these two parts, they are somewhat similar, but this array, capital array, it has been replaced by the small array. So what are those capital array, small array, etc.? Basically, with the capital letters, we are denoting the bigger wheel, that is the gear, okay? And with this small letter, okay, we are small. These are letters are for the smaller wheel, that is the pinion. Okay, so that is what, so path of contact and path of pressures actually like this. Okay, and what is this r a? One is r suffix a, another is only r. Similar is the case here, r suffix a and another is only r. So that r suffix a, it is nothing but the, it is addendum circle radius or the addendum radius. Okay, addendum circle radius, and only r whatever we have, that is nothing but the pitch circle radius. Okay, so this r represents radius and r suffix m is the addendum circle radius, only r is the normal pitch circle radius, that is the we already know. Similar is the case here. So this phi, these are nothing but the pressure angle. So and the other rest is similar, cos phi by pi m. Okay, so this part is, this is known thing. Okay, directly we can utilize, no problem. Path of across plus path of recess, it gives you the path of contact divided by cos phi into pi m. Now what are the unknowns here that we have? So we don't know about this addendum circle radius, it is not given in the question. Similarly, the pitch circle radius not given in the question. Okay, and similar is the case for pinion. For both the gear and pinion, these are not given. So phi is given as 20 degree. So no problem. Okay, but what we know, we have been given the we have been given like this module. Okay, and we know what we know, or only sir knows. So what we know from our previous knowledge, so r is, that is radius is nothing but diameter by 2. Okay, and how we know this like module and diameter, they are connected. So module is nothing but d by t, that is the pitch circle diameter by divided by the number of teeth. So this is valid for both gear as well as for pinion. But the corresponding diameter, pitch circle diameter, as well as the corresponding number of teeth, you have to consider. Okay, so what we can write from here? So d can be written as m into t. Okay, from here we have just obtained. So d can be written as m into t divided by 2. Now, if we are talking of this particular, this part is the capital letter, these are for the gear. Okay, so capital letter for gear. Similar is the case. We are going to find out this pitch circle radius for the and addendum circle radius for pinion also. Now we have r equal to mt by 2. So m is already given as 3 mm. Okay, 3 is the module, and t, number of teeth on the gear, just now we have found out to be 51 divided by 2, which gives you 76.5 millimeter. Okay, now that is about this pitch circle radius r. Now we also have to have the addendum circle radius. Now how we can find out addendum circle radius? So for this, if you know what is addendum and all, so it will be very evident. So now suppose consider this diagram. Okay, so now these are the teeth that we have. Okay, so this is the teeth, this is another teeth and all. Okay, and we know this circle, what is this circle? Can anyone tell me this circle which is passing through the pitch points? This one, the middle one. What is this circle? Can anyone tell me? So this is nothing but the pitch circle, and the corresponding. I think the power is out within short time. The screen might not be visible, and the corresponding this one is radius is pitch circle radius, and this part is what? This part is nothing but the upper part is addendum. Yes. Okay. So
Yes.
Now,
Yes, sir.
if I add this pitch circle radius and this addendum value, okay, then it gives me this much. That means this black portion plus this yellow portion will give me the total addendum circle radius, right? So this plus this gives you addendum circle radius. That is the addendum plus the pitch circle radius gives you addendum circle radius. Understood up to this much? Yes. Yes or no?
Yes, sir. Understood.
Okay, so the power is actually out in our college. Okay, so it may take some time to like this one to say once again restore the internet and all. Okay, so within that time the screen will not be visible. I think you are seeing black screen or what? Yes.
Yes, sir. Black.
Okay. So if you can follow, actually, if you can follow me, I think the whole thing is over. So up to the figure you have seen, right? So how we can find out the addendum circle radius RA? That figure you have seen, all of you have seen, right? That is addendum circle radius. We can find out by the addition of the pitch circle radius plus that addendum value, right? Up to this much, all of you can follow me.
Yes, sir.
Okay. So now what we have done in the next step, it is only that only. So addendum value is already given in the question. It is 1.1 times the module. It is given like that. Okay. So just we have just put that value only, nothing else. So our just now we have found out the radius value, pitch circle radius plus 1.1 times the module, which is nothing but which is given as the addendum. Okay. So that will give you some value, right? Some in millimeter. Similar is the case, exactly similar case you can do for the pinion also. That is small r you can find out exactly by doing the same thing, but you just have to find out, consider the values of the values from the pinion, diameter value as well as not that. Okay. Next thing, uh, what we are going to do, this whatever we have just found out ra and r, okay, so we are just going to utilize it in the expression just now whichever has been shown. Okay, so in that expression only we'll just put that value, and if you just solve, you're going to get an answer. The answer itself will be the answer for the this one, your contact ratio. Okay, if you have written values, in your copy, can anyone just solve it, how much it is coming, check how much it is coming. The trick was only with the thing is you should know about the part of contact and part of recess. If you part of approach part of recess, and that expression if you just add them, that is nothing but the part of contact. So the known expression we already have, and after that the rest is just by you just have to know that the addendum circle radius r suffix a you can get by adding the pitch circle radius plus the addendum value. Okay, so just try it, check the value how much it is coming. In the meantime, I'm restarting my laptop, and I'm trying to connect with the internet. Check what kind of values you are getting. Anyone trying to solve it now? Just you just have to put the values, nothing else, and solve it. Actually, if you have tried, it should come something like 1 point something, okay, 1.7 or so, okay, that kind of values it will come. And can anyone tell me if I get n, that is the contact ratio value as 1.78 or 1.7, then what's the meaning of it? So actually, this has completed the problem. Once you know about this array, you have found out. Okay, just now similar is the thing for pinion for both the things you are going to do. Okay, for your gear as well as for pinion. Okay, and after solving whatever value you get, that itself is the answer. Okay, and that completes the problem. And if I am not mistaken, so for this particular problem the answer was something around 1.7. So the contact ratio n, if the value is 1.7, can anyone tell me what's the meaning of it? We have already discussed in one of the class. Hello, I believe I'm audible. Am I audible, guys? Yes, am I audible? Hello.
Yes, sir.
Okay, thank you. So, can anyone tell me if suppose if I get after solving, if the answer is something like 1.78 that we have obtained, so what's the meaning of it? Okay, so we have restored internet and I'm sharing once again. Okay, I think it's visible now. So after that, rest is on the similar thing only. So R value we have just found out. Okay, next RA will find out by adding pitch circle radius with the addendum. Addendum is given as 1.1 times the module. So R we have just found out, and 1.1 into 3, that is the module, and we have obtained some value. Similar is the case for your pinion. Okay, R mt by 2 we can write, and we'll be using the corresponding teeth value just now we have found out. And similarly Ra, it is nothing but R plus, this is small r, plus the addendum. Okay, so we'll find some value, we'll get some value, and after that these values we have just put in the expression, known expression, and we have found out n to be 1.78. So and what's the meaning of it? So this 1.78, it is like this value is n value is greater than 1, okay, and less than 2. Okay, so 1.78 is definitely greater than 1 and less than 2. So basically what is the meaning of 1.78 contact ratio? So one pair of the teeth will always be in contact at all time, whereas during this 0.78 means during 78% of the time two pairs of teeth will be in contact. Understood? That is the meaning of 1.78. Because it is contact of the teeth, they are kind of whole number only. Okay, we cannot say that this fraction of teeth are in contact or so. So whenever meaning is with respect to time, one pair of teeth, it is always in contact. Minimum one pair is always there, and for 78% of the time of contact, okay, two pairs of teeth will be in contact. Understood? So this completes this problem. Let me know whether you have understood or not.
Understood, sir.
Okay, thank you. Next, we have okay, I think they are releases. Okay, similar kind of problem only, but here they are asking like 1 point length of path of contact also you find out, and what is the angle turned by the pinion. So that is the difference. So rest is similar only. So 1.1 time dp, that is the diametral pitch is given in terms of module. So that is what is the difference. So diametral pitch we know it is nothing but the reverse of your the module we can get by reverse of this particular diametral pitch. Okay, so from there we'll be able to find out module. Rest is similar to the previous case, addendum, circle, radius and all. Okay, and I'll be sharing this. Okay, rest is similar, rest problem is similar. So here they are asking like length of path of contact. So from the previous question, what we have done in the previous question, it was path of contact. The whole thing we have utilized here divided by the circular pitch. Okay, so they are right now asking only about this particular path of contact portion. So this will be this particular upper portion. After that means step by step they are asking. Okay, next is length of arc of contact. So path of contact divided by cos phi gives you arc of contact. Next, arc of contact divided by circular path pitch gives you contact ratio. Okay, so it is similar to the previous problem only. Only difference is the diametral pitch is given as 1.6 in terms of the module. Module we have to find out by utilizing the reverse of reciprocal of your diametral pitch. That is the thing that you should know. Next thing is similar, the addendum circle radius, it is pitch circle radius plus addendum, those things are given. So this problem, this much we have already done in the previous case, and this is the thing, this is different. So angle turn by opinion during this contact, how we can find out? See, this is, see, we know if the contact length is 2 pi r, what is 2 pi r? It is nothing but your circumference for a particular circle, and gears we can consider like a circular kind of thing only. So whenever contact length is 2 pi r, that is the equivalent to circumference, what will be the angle turn? Angle turn is the whole 360 degree, one complete revolution. So if this is the circle, okay, the circumference means the whole revolution. If you consider that completes the circumference, and for your circle, we know circumference is given by 2 pi r, and angle turn will be 360 degree. If we consider like unitary method, then for contact length of 1 unit, it will be 360 divided by 2 pi r. For contact length equal to arc of contact, it will be 360 by 2 pi r into arc of contact. That means whatever the arc of contact, if you know, using that and multiplying it with 360 degree divided by circumference, you can get the angle turned. So that is what we have utilized here. In the next portion, they are asking about the angle turn. If it is for pinion, you will be corresponding pinion values you will be utilizing. If they ask you about the gear, the corresponding values for the gear you will utilize. Rest is similar in this particular problem. That's why we have not gone through in details. But what is different, that we are asking. So here, angle turn, length of arc of contact, that we have found out in the previous portion, divided by 360 divided by circumference of pinion. So if this is pinion, you'll be using the pinion value. If it is gear, you'll be using the gear value and on. And after that, you will get the angle. Okay. So with this, we have completed this problem. Understood? It is a different problem, but we have not gone through in details. But whatever is required, whatever is changing with respect to the previous problem, that much we have discussed. Okay. So I hope all of you have understood. Let me know. So we'll stop here for today.
Yes,
Whether you just let me know whether you have understood or not. Okay, okay. Thank you, Kandi. So
sir, class test 2 syllabus.
class test to syllabus, we still have I think 10 days and all. Okay, so definitely that means this whole module will be there definitely. Okay, because within next class maybe this module will be over. We can even start the next module. So whatever portions we have not covered in second module in class test 1. So we'll start from there, and this particular module, the whole module will be there. Okay. So gear module will be there, the whole thing. And from second module, from chem module, I think the only the starting portion we have covered, the classification, etc. in the first class test, right?
Yes, sir.
Okay, so from there, okay, that means whatever is left, the chem module, the remaining portion from the chem module, considering all those chem design and all, okay, those things, and this particular module, gear module. Okay, the next module will not consider. Or do you want the next module? Because we'll be getting some classes in between. Do you
No,
want the
sir.
next module also? Okay, no. Okay, then this is the class test one, class test two syllabus. That is the remaining portion of. Sorry, remaining portion from CAM module plus whole gear module. Is it visible? Whatever I have written. Yes, is it visible? Remaining portion from the CAM module, considering all those CAM design and all, and whole of the this particular module, whatever we have considered. Okay. So with this, we'll stop here for today. Thank you everyone for joining. Once again, we have lost connection, internet in college. Okay. Thank you everyone. We'll stop the meeting here. Thank you for joining.
Thank you, sir.
Thank you, sir.
Okay. We'll end here.